In this video, we're going to introduce the polars package in Python for data analysis. This is a modern alternative to Pandas that you can use when you're analysing data. Now, polars just reached version 1.0, so it's stable and ready to use, and the API should be relatively consistent from here on. We're going to dive in this video and learn the main concepts around the package and why you might want to use that instead of, for example, Pandas. So let's get started. I'm on the homepage for polars and there's a link to this in the description of the video. DataFrames for the new era. So like Pandas, the main data structure in polars is a data frame. And you can see some of the stats around the package. 46 million downloads to date, 27,000 GitHub stars. So it's a very popular package. And a lot of people these days seem to prefer polars to Pandas. So we're going to dive into it in this video. Now, polars is very fast. It's written in Rust. And it's also designed for parallelism. And it uses vectorized and column-based processing, and that can be very efficient when you're analysing large sets of data. And polars is also easy to use, and it's an open source package. Now we're going to dive into the code here. At the end of the video, I'm going to go over this section here, which is a comparison between polars and Pandas. But what we're going to do to start with is we're going to install polars and we're going to use it in a Jupyter notebook. Now I'm using Python 3.12 here, and I have an import here. I've already installed polars, but if you need to install it, what you can do is you can run the pip install polars command. Now, if you're using an Anaconda distribution, you can open the Anaconda prompt and you can type in that command, pip install, and it's polars. When you run that, that's going to install it into the base environment for Anaconda. So that will then make it available here in the Jupyter notebook. So once we've installed polars, we're going to start using it now. So I'm going to create a bunch of cells here and just give ourselves some space to work with. Before we do that, I want to go back to this page one more time. There's something I forgot to mention, and it's this key line here that compared to Pandas, polars can achieve more than 30 times performance gains. So it could be potentially a much more efficient package to use if you're processing large volumes of data. Now we've imported polars as PL. We're now going to cover the basics of the package using some hard-coded data. Now, as the documentation said, polars provides data frames, but it also provides series objects, just like Pandas. So we're going to create one of these just now. I'm going to call the variable series, and we're going to instantiate a series object by using the pl.series constructor. And we're going to give it a single column. That's what a series is. It's essentially a one-dimensional piece of data. And let's say we're representing some ages here. We can pass a Python list of numbers in here for the ages that we're representing. And then if we look at the series just below here, we're going to see the data structure printed out on Jupyter Notebook. So the series that we've created here has a name of age, and it represents a set of ages here. Now, a series is a one-dimensional data structure, whereas the data frames that we're going to look at very soon, these are two-dimensional data structures that are more similar to something like an SQL table or an Excel sheet. Now, when we have a series of data like this, we can perform aggregations. For example, if we wanted to get the maximum value in the series, we can use the .max function, and that gives us back 77, as you can see below here. And we can also call other aggregations, such as the min function, to get the minimum value. And we could also, as an example, sum up all of the values in the series, and that gives us back another number. Now, as well as aggregation, we can also sort the values in this series. We can just call the .sort function in order to get a natural ordering over the series. So we have the ages here, and now it's sorted from the lowest to the highest. If you need the reverse order, you can pass the descending parameter and set that to true, and that will give you back the highest value first, as you can see here. Now, interestingly, as well as these aggregation and sorting methods, there's many other things you can do with a series. I want to show one more before we move on to data frames, and that's the toPandas method on a series. If we execute that, it's going to convert the polars series object to a Pandas series. So by using polars, you can very easily convert back to Pandas if you have some downstream work that requires Pandas data frames or maybe the NumPy arrays that underlie these data frames. Very easy to go from a series object to the Pandas equivalent, and that might be useful, as I said, if you have these apps that require the Pandas data structures. Now, series are very simple, but I want to move on now to data frames in polars. So let's clear this code, and what I'm going to do is define a variable called df, and we can create a data frame by using the polars.dataframe constructor. And we can pass a Python dictionary of data to that. So I'm going to do that just now. And I'm actually going to paste these in just so that we can speed up the tutorial. So I've now pasted this data in, and we've also imported the date object from Python's datetime package. So we're creating a data frame and we're passing a dictionary containing some keys, so employee IDs that map to numbers, we have the names of the employees, as you can see here, and we're passing some ages, a department for each employee, and a salary, as well as a start date. So this data frame has 6 columns, and it contains a range of data, for example, numerical data, string-based data, and also Python date objects. Now we can pass different options to the data frame, as well as the data itself, as you can see here. But we're going to keep it simple for now, and when we look at the data frame, you can see below we get a 2-dimensional view of this data, where we have columns with the given names, and each row represents a single employee in this data frame. Underneath the column names, you can see the data types, for example, date, float 64, string, and so on. And this is essentially what a data frame is. It's a data structure consisting of rows and columns, where the columns have a data type and a name, and the rows represent a single observation of the given data. Now we have methods that are exactly the same as Pandas. For example, if we wanted to see the first 2 rows of the data frame, we can use the DataFrame.head method. And as you can see below, that gives us the first 2 rows of the data frame. We also have a tail method if you want to look at the end of the data frame. And as well as these, we can get summary statistics for the data frame by calling the describe method. So what that's going to give us back is a look at each column in the table, and it's going to give us some summary statistics for each column. So for example, the employee ID, we can look at the count, we can look at the mean values because the data type is numerical. We can also look at standard deviations and minimum and maximum values, as well as quartiles. So by calling .describe, we can get a good overview of what kind of data is in each of the columns in the data frame. Some of the columns contain string values, for example, so it doesn't make sense to calculate a mean for those, but we can still get some useful statistics here. But it's most useful if you have numerical data. And interestingly, for the date-based column, you can actually compute an average over the date. And as well as describing the data frame, we also have a property on the data frame object called 𝗬𝗵𝗽𝗁. If we look at that, we can get a very quick overview of the columns that are in the data frame, as well as the data types for each column. Let's now move on. We're going to look at selecting specific columns in the data frame. So I'm going to remove this output, and we're going to go to the cell below here. And what I want to do is get a subset of the columns in this data frame. So let's say we only wanted the name and the age columns from this data frame. What we can do here is we can go to the cell below, and we can create a variable here called DataFrame selected, and we're going to call a method on the data frame called select. And what we pass into that is a list of the columns that we want to get back from the data frame. So I'm going to get the name column and the age column, as I just said. When we get that back, we can look at DataFrame selected just below here, and we can see the output that we get. We only get the 2 columns that we selected here in the list that we passed to the select method. And you can think of this as being similar to a select expression in SQL. Instead of selecting every single column in a database table, you might want to get a subset of the columns, and you can pass the column names as a mechanism to do that. And if we needed to get another column, for example, the salary column, we could copy the value of that and add it to the Python list. And when we execute this again, we get back the same 2 columns, but we also get back the salary column. Now in Pandas, there was a different way to do this, and I'm going to show that that method applies in Polars as well. We can reference the original data frame, which has a name column, and if we do that, we get back the series containing the name. And this syntax is exactly the same as it is in Pandas, and we can also pass multiple values into this data frame index. So in order to do that, we just pass the list containing all of the column names, and that will give us back these columns that we are interested in from the data frame. So very similar syntax to Pandas when we want to select particular columns from our data frame. Now what if we want to select specific rows from the data frame? So let's have a look at the data frame. We have different rows, 5 of them. We might want to get back a specific set of rows based on some condition. For example, we might want to get all employees who have an age that's greater than or equal to 30. And you can see that there's 2 employees here that have an age that's less than 30. So we want to filter them out. How do we do that using Polars? Let's go to the cell above here, and we can use a method here called filter, and we pass a condition into that. So we're going to select the age column using the pl.column construct, and we can check that that's greater than or equal to 30. If we execute this, we only get back the rows in the data frame below here where the age is greater than or equal to 30. So the DataFrame.filter method takes a conditional or multiple conditions, and it's going to return to you only the rows that match whatever the conditions that you pass in. Now another example of a condition that we could apply here is we could check for only employees whose department is equal to, let's say, finance. So I'm going to copy that, and we're going to change the condition here and reference the department column. And instead of greater than or equal to, we're going to check for an equality here, and the string we're passing in is finance. When we execute that, you can see below the data frame that's returned contains 2 rows. Both of these employees have a department of finance, so that's how we do that filtering in Polars. Now we can also provide multiple filter conditions, and that's very easy to do. We just need to pass multiple arguments to the filter method. So we've got this single condition where employees have a department of finance. We can just add another argument here. We're going to reference the salary column, and we're going to check for employees whose salary is greater than, let's say, 52,000. Now I'm going to execute this, and you can see we get back 2 members of staff here. Both of these employees have a department equal to finance, and both of them have a salary that's greater than 52,000. Now if I change this to 62,000, that's going to remove that employee whose salary was below this. So this is how you apply multiple filters to the data frame. You can simply specify them as arguments to the function, and you can pass as many of these arguments as you want. Let's now move on, and we're going to look at adding and dropping columns from the data frame. So we have 5 columns. Actually, we've got 5 rows. We have 6 columns in the data frame. What if we wanted to add a new column to this data frame? So let's say we want to take this salary column in the data frame, and we want to calculate the monthly earnings for each employee. So we're going to take the salary and we're going to divide it by 12 and add that to a new column that we're going to add to this data frame. So let's go to the cell here. We're going to use the DataFrame.WithColumns method, and we pass an expression into this. So I'm going to reference the salary column that we have in the table, and we're going to divide that value by 12. Now let's see what happens when we execute this. And I said 12, but I typed 20 for some reason, so let's fix that. And then we're going to use the .alias function after we define that expression, and we can give a name to the resulting column. So I'm going to call it monthly earnings, and then we can close off the expression. Now when we execute this, look at the data frame just below this cell. We should hope to see a new column being added here. And you can see that on the right hand side. It's taken the salary and it's divided it by 12, and it's added the result of that expression as a new column into the data frame. Now you might notice that the decimal points here, the values after the decimal point, we're getting quite a lot of those. You might want to round the output, and you can use the .round function to do that. If we now execute this, we can get back values that are rounded to 2 decimal places. So the syntax here is you use the WithColumns method on the data frame, you pass an expression in for the new column that you want to add, and then you can pass optional expressions after that, for example, to round the output to 2 decimal places and to give the output an alias. That will then appear in the data frame. So that's how we can add a new column to the data frame. That's one way to do it. One thing to note here is that this is not an in-place operation. So if we go down to the cell below and we look at the data frame, it does not have that new column that we just added. So in order to persist that into the data frame, we need to reassign the value here. And when we do that, if we look at the data frame below now, we can see the new column is still there. Now what happens if you want to drop a column or delete a column from the data frame? So let's say we don't actually need this monthly earnings column anymore. We can use the DataFrame.drop method, exactly the same as Pandas, and we can pass the name of the column that we want to drop. So I'm going to pass the new column in here, and then when we execute that, the column is removed. Again, that's not an in-place operation, so if we look at the data frame after that, it's still got that column. So again, we will need to reassign the value here after calling drop. Once we do that, if we look at the data frame again below, it no longer contains that column. So the WithColumns and drop methods on a data frame, they are not in-place operations, but they return new data frames with the expected output. So if you need to replace your original data frame, you can do that by reassigning the result. Let's now move on to some other methods on data frames. We're going to look at sorting data frames. Now we saw how easy it was to sort a series object in Polars. With a data frame, we have multiple potential columns that we want to sort on. So in order to do that, we can use the DataFrame.sort method, and we can pass the name of the column we want to use for the sorting as an argument. So for example, if we sort by salary, when we execute this, you can see that the employees in the resulting data frame are sorted from the lowest salary to the highest. And again, we can pass that same parameter as we did with the series, and that's the descending parameter. We can set that to true if you want to get the values from the highest value first down to the lowest. And interestingly, Polars also knows how to sort dates. So we have a start date column here. I'm going to pass the name of that column in as the first parameter here to the sort method. When we execute that, the data frame we get back here is sorted with the most recent date at the top of the data frame, and that goes down to this date at the bottom. And this is the date that's furthest away in the past. So it's very easy to sort the data frame. We're now going to move on and we're going to look at grouping and aggregation over a data frame. So we saw earlier on how to calculate very basic statistics on a series, for example, getting the maximum value in a series. With a data frame, it's very similar. We can access the column that we're interested in, and we can call the .max function there, and that's going to give us the maximum value across the entire data frame for that column. And we could do other statistics, for example, to get the median age, we can use this function here called median, and we can see the median age is 31 in this data. Now we can also perform aggregation on filtered data, so let's look at the data frame here. Let's try and get the maximum salary from all employees whose age is greater than 30. We can do that by accessing the DataFrames filter method, and we're going to pass the column in here, and that's the age column, and we want to get all employees whose age is greater than 30. Once we've done that, we can access the salary column for the filtered employees that remain in the data set, and then we can call .max, and you can see we get back this value here. And if we call .min, we can get back 60,000. So if we look at the original data frame again, when we look at all of these employees whose age is greater than 30, you can see the minimum salary is 60,000 because the ones that are less than 30 have salaries that are less than 60,000. So I hope that makes sense. You can filter your data frame and then apply these aggregations after the filtering. Let's now see how we can group by a column in the data. So I'm going to look at the data frame here, and let's say that for each employee we want to calculate the average salary for each department in the data. So 2 of these employees have a department of HR, 1 has a department of engineering, and 2 have a department of finance. We want to group by that department column and then calculate the average salary over the resulting groups. Now this is similar to a group by statement in SQL. With that you can create groups on a single column, and then every single row in the table you assign each row to a group based on their particular value in that column. So if 2 rows have the same value on the grouping column, they're going to be assigned the same group. For example here, the HR employees, and that's the records 1 and 4, will be assigned to the same group. Now we can perform grouping in polars, and that's done by using this group by function on the DataFrame object. Now the DataFrame function takes the column that we want to group by. In our case that's going to be department, and it's going to return a group by object. So what we need to do here is we need to apply some aggregations to this group by object. We can do that by calling the ag method on the group by object, and that's short for aggregate. And this method takes a list of aggregations that you want to perform. So we're going to reference that salary column because we want to aggregate the salaries for each grouping by department. And the aggregation function that we're going to use is the mean function. We want to calculate the average salary for each department, and we're going to give the result an alias that we're going to call average salary here. And don't forget to close that list at the end here. When we execute this cell, you can see what we get back below here. We have each department, each distinct department I should say, on the left hand side, and on the right hand side we have the average salary that's been computed for each of these departments in the data set. So we can see that finance, an average salary of 72,500, and so on. Now we can pass multiple aggregations to this function here. At the moment we're passing this single aggregation. And let me fix the syntax here. I think this would be clearer if the list was on a new line. So we are passing a list that contains a single element at the moment, but we can pass as many as we want. So after we group by department, let's also imagine that for each department we wanted to find the youngest age in the group of data that we have here. We can add a second aggregation for this, so we can add another element to this aggregation list that we're passing. The column that we're interested in is the age column, and the aggregation function is the min function. And again, we can provide an alias for the resulting value, and I'm going to pass youngest age as the alias. So for each department that you can see here, such as finance, engineering, and HR, we can get the average salary as well as other aggregated data, such as the youngest aged employee in that department. Now I want to move on. We've got a couple of sections to go here. We're going to look at null values and how you can handle them with polars. We're also going to look at how you can serialize data to files and from files. And we're also going to look at the end of the video on plotting with polars and how you can take the data in these data frames and plot them out and visualize them more effectively. So let's get started with that. I'm going to remove the code that we have here, and also remove this data frame. And I'm going to redefine the data frame here. So we're using the polars.dataframe and we're passing the data to it. But notice that for the salary column, as well as the salaries, I'm passing a couple of null values here. And that's the Python none value. So I'm going to execute this, and that's going to give us back a new df DataFrame object. When we look at that below here, you can see the null values in the salary column. So I'm going to show some methods now that Polars provides on the data frame to help you with null values. For example, we have a null count method, and what that's going to do for each column in our data frame is it's going to give us back the number of null values in that column. And you can see for the salary column, we've now introduced the 2 null values. We get back 2 here. We can also get back a true or false value for whether a particular column has null values. And we can use the DataFrames select method, and we're going to pass the column of salary here. And then we can call the isNull method, and we're going to see the output of this. You can see that for this particular column, the first 2 rows here were not null, but the 3rd and 4th rows were null, and that comes back as true in this output here. So for the given column, we're checking every single value that appears in each row, and we're getting back a true or false value if the value is null. Now we can combine this isNull method on the column with the filter method on the data frame. So if we wanted to see all of the rows in this data frame where the salary column is null, what we can do is we can call DataFrame.filter as we saw before, and we're filtering the data frame down here to only the rows where the salary column is null. So when we execute that, you can see the output below here. There's 2 rows here, and for each of them, the salary column is null. Now, what about the inverse? We might be interested in only the rows that are not null. And there's a method isNotNull that we can use if we want to get back that. So now you can see the salary column contains values for each of these rows, and the null values have been filtered out. Now, what if you want to fill in the missing values using some kind of strategy? So if we look at the data frame, let's take the salaries that we have here. What if we wanted to replace the null values with some kind of value? There are different strategies for doing this in Polars, very similar to Pandas again. So we're going to use the DataFrames with columns method that we saw before, and the column that we're looking at is the salary column. And Polars provides a method called fillNull, and we can fill these null values with a literal value by using polars.lit, and the value of 50 is what I'm going to pass in here. So let's execute this. And I don't think I've terminated that properly. There's one more bracket to add here. When we execute that, you can see the null values have been filled in with the literal value of 50. So that's a very easy and simple way to replace the nulls with some kind of literal value. There are more sophisticated strategies that we can use here. So what I'm going to do is remove this. So we're going to pass a strategy here of forward, and we're going to see what that does in a second. When we execute this, you can see what happens here. Now, these were the 2 null values before. They have now been filled in with the value of 75,000, and that comes from the row just before those 2. So basically, with the forward strategy, you take the previous non-null value and you move that forward into the next null values until you hit the next valid value, which in this case is 85,000. And as well as forward, there's also a backward strategy. When we execute this, you can see below here that what happens here is it's doing the opposite. It's taking the value of 85,000 and it's propagating that backward to the previous values that were null. And one last one to show here, I'm going to go back to this method here. We can remove the fillNull method and we can use the interpolate method. So let's execute that, and what's happening here is it's going to interpolate between the 2 values that are not null, so that's 75,000 and 85,000. And it's going to calculate the even values between those for these 2 records that are null. So 75,000, it goes up to 78,333 and so on. So that gives you a way to interpolate between values that are not null and fill in the data with that interpolated value. And interpolation might be useful, especially if you're working with time series data. So that's something to consider as well if you're handling these null values. Let's now very quickly look at serializing data using Polars. So if we look at the data frame that we have here, let's imagine we wanted to write this to a CSV file. It's very easy to do that. We can use the DataFrames write CSV method. And I'm going to provide a name for the CSV file that we're going to write to. Let's say employees.csv. And as well as write CSV, we also have other methods such as write JSON. So if we wanted to write this data to an employees.json file, we can also do that. Let's execute this cell, and if I go back to the Jupyter Notebook display here and refresh this page, You can see the files that we have here. We have the Python notebook, but we also now have an employees.csv file. And if we open that up using Jupyter Notebook, you can see the CSV file has the same column headers as the data frame, and it's filled out the CSV with that data. So it's very easy to use polars to write your data to different files. And you can also read in data from these files. So for example, if we want to define a second data frame, we can use the polars.readCSV method. And we can copy the name of this CSV file and pass that in here. And that's going to read that data from the file into the data frame. So if we look at data frame 2 here, we're going to see hopefully that it's been successfully loaded back in to the data frame. Now you might need to perform some changes when you load that data. For example, the start date column has been changed from a date type to a string type, but you can specify arguments to the readCSV function that can help you with that. We're not going to go into that in this video, but you can check the polars documentation if you want to know more about that. Let's now move on to plotting. What I'm going to do is go to the polars documentation on plotting. So the logic for plotting does not come from polars itself, but it's being deferred to this package called hvplot. So when you install polars, it's also going to install hvplot, and you can then create charts and graphs based around the data that you have in your data frames. So let's do 2 very simple plots to finish the video. I'm going to remove these lines of code that we have here. We don't need that second data frame. What we're going to do is use the data frame that we do have, and we're going to reference the age column in the data frame. And we can get a reference to the plotting API using the plot property on the data frame. And for example, if we wanted to render a bar chart here, we can call the .bar function. And when we execute that, it's going to generate a bar chart. So what we've done here is we've taken the age column that we had in our data frame, and we've plotted that out into a bar chart, very simple bar chart here. And if we move the y-axis to 0, we can see this a bit more clearly. So we have the values. It doesn't look amazing, but that is a very simple way to plot your data. And you can pass parameters to this function that allow you to customize the plots that are generated. Now we could also create a scatter plot to see how the employee's age and their salary are correlated, if at all. So let's look at the data frame again. We have different ages and different salaries. And note that the salaries here are null. So what I'm going to do is actually fill these values in, because we don't want to be working with null values when we're trying to plot this data out. So I've now filled that in with the original values for the salary that we had at the start of the video. Let's now see how we can define a scatter plot around this data. So what I'm going to do is refer to the data frame, and again we're going to get access to the plotting interface. And we're going to call the .scatter method to generate a scatter plot based on this data. Now we need to provide the column that we want to use for the x-axis and the y-axis. So for the x-axis, we're going to look at the age of the employee, and for the y-axis, we're going to look at their salary. And I'm going to pass another argument here, and we're going to reference the name column, and that's the by argument. We're going to see what that does as we execute this code now. So let's look at this and look at the scatter plot that's been generated here. On the x-axis, we have the ages of the employees, and on the y-axis, we have the salaries. So we can see if we're looking for a kind of trend in this data, and this is completely fake data, but let's imagine it wasn't. We only have 5 data points, but we can see a clear upward trend here. As someone gets older, their salary in this imaginary data tends to increase. That's the purpose of a scatter plot. It allows you to compare 2 of the variables that you have in your data to see if there's any kind of correlation or patterns in that data. Now the by parameter, we pass the name, and you can see that's generated this legend on the right hand side of the chart. So that tells you which employee each scatter point represents. So it's very simple to take your data frames and polars and generate these plots based on the data that's in that particular data frame. Let's finish the video by looking at this comparison to Pandas. Now I'm not going to read through all of this. Let's look at the right hand sidebar though. One of the key changes is that polars does not have a multi-index. That's something that you can use in Pandas, but it's not present in polars. So data frames are always going to be 2-dimensional tables in polars. And one other difference here is that polars adheres to the Apache Arrow memory format to represent data in memory, and that's opposed to Pandas, which uses NumPy arrays. So Apache Arrow, this is an emerging standard for in-memory columnar analytics, and it can accelerate your data load times, it can reduce your memory usage, and it can accelerate calculations. So in polars, you can convert data to the NumPy format using the toNumPy method, and we also saw earlier on the toPandas method as well. And here's a key point in terms of performance and efficiency. Polars has more support for parallel operations than Pandas. And the reason for this is that Polars exploits the strong support for concurrency in the Rust language that it's written in, and that enables it to run many operations in parallel. And it's actually much harder to do parallel processing in Pandas, and that's because the core of Pandas is single-threaded, and you need to use an additional package such as Dask if you want to parallelize your operations. And also, Polars can lazily evaluate queries, and it can also apply query optimization. And that's something that differentiates it from Pandas. If you want to know more about all of these, I'll leave a link to this page in the description. And you can also look at the key syntax differences between the two packages. We already saw some of this earlier on. For example, there is no lock and iLock methods in Polars as they are in Pandas. Instead, we can use the select method and also the filter method if you want to select particular columns or you want to select particular rows from DataFrames. Now, I'm not going to go over the entire documentation. I'm going to leave a link to this below the video. The key points though are that Polars provides a lot of good constructs for making your queries and making the processing that you're doing on your data more efficient than with Pandas. And it does that without you having to think about it. It's just taking advantage of the fact it was written in Rust and it uses these Apache Arrow compliant formats in order to process and store data. So that's all for this video. We've covered the Polars package in Python in detail, and we've seen some of the main constructs and main operations that you can do using the package. If you're interested in more videos, I'd love to make more. Let me know in the comments. Maybe we can take a real life data set and analyze it using Polars. And I've been thinking also of doing a comparison video between Polars, DuckDB and Pandas. If you're interested in that, let me know. Thanks for watching. If you want to support the channel, we have this Ko-fi page that's linked in the description. Any kind of support there would be greatly appreciated. If you've enjoyed the video, give it a thumbs up and subscribe to the channel for more. Thanks again for watching, and we'll see you in the next video.